So what if I told you that the secret to making science class amazing today was actually figured out like 30 years ago? Well, we're about to take a little trip back to 1993 because we're going to unpack a PhD thesis that, believe it or not, laid out a timeless blueprint for making science education genuinely engaging.
All right, so let's get right into it. Take a look at this. It's a PhD thesis from way back in July 1993. And what's so cool about it is that it used some pretty heavy-duty statistical methods to find a real proven answer to a question we're still asking. How do we actually improve the way we teach science in our schools?
But before we jump to the solutions, we've got to understand the problem. What was the researcher Ganapathi Rao actually trying to solve back in the early 90s? I mean, what was so wrong with science class back then?
Well, this thesis, it does not pull any punches. It gets right to the point, saying that the teaching methods at the time were, frankly, just uninspiring. The exact word he uses is dull. And yeah, that's a pretty perfect word for a class that just wasn't capturing anyone's imagination.
And it didn't stop there. The thesis points out another huge flaw. See, science felt, abstract, right? It was just trapped in textbooks. There was this massive disconnect between what was being taught in the classroom and the actual real world right outside the window. So this all led the researcher to a really key insight. The answer wasn't going to be found in the standard curriculum. Nope. He realized he needed to find and then test activities that were outside of the regular stuff. He called them para-academic activities, and the whole point was to finally bridge that gap and make science, well, exciting. Okay, so how did he go about finding the best activities? Well, the investigation cast a super wide net. I mean, they explored a huge range of possibilities for what schools could be doing to really bring science to life. Get this, the study looked at 20 different ideas. And we're talking about the whole shebang here. From stuff you'd expect, like science clubs and field trips, to some really creative ideas like maintaining a school garden, keeping an aquarium, or even using drama to explain science concepts. Wild, right? Okay, and this really is the million-dollar question, isn't it? When you've got 20 different options, how do you figure out which ones actually work and which ones are just, well, noise? That's the exact question this whole study was designed to answer, using some serious statistical analysis. Now, this is the part I find really cool. We get to see the scientific method being used on science teaching itself. It's like we get to watch as the researcher just systematically sifts through all that data, filtering out the duds to find the absolute gold. So the analysis kicks off, and right away, some ideas start getting cut. For instance, if you look at the data here for what's called Factor 13, you see things like science display boards just getting dismissed. The numbers simply showed they didn't have a strong enough impact on learning to be a key factor. So, gone. And that filtering process just keeps going. Here, in Factor 10, we see activities like science festivals and even having an aquarium getting ruled out by the statistics. Look, they're interesting ideas for sure, but the data was pretty clear. They just weren't the most impactful. And again, you can just see that funnel getting narrower and narrower. Things like organizing trips to science museums or having guest speakers for science talks, they were all analyzed, but they turned out to be less significant than some of the others. The search for the best of the best was still on. So after all of that intense number crunching, that huge list of 20 potential activities got whittled down to just 13 statistically relevant factors. But it gets even better. From those 13, only 4 came out on top as the clear, undisputed winners. All right, so this is it, the moment of truth. After weeding out everything else, what did this incredible deep dive from 1993 say were the absolute best, most powerful ways to make a science class come alive? What made the final cut? Well, the answer is laid out crystal clear, right here in the final conclusions table. The research points to the 4 most important factors, and it even ranks them by their statistical weight, basically telling us what percentage of the positive change each one was responsible for. Coming in at number 1, and by a huge margin, I mean huge, was the organization of science projects. Just think about that for a second. This one thing accounted for over 43% of the positive impact on learning. It wasn't just another activity on the list, it was the absolute undeniable champion. Next up, in second place, was creating and running a science club. And this makes so much sense, right? It gives students a dedicated,
ongoing space where they can explore and experiment, all without the rigid structure of a normal class.
Third on this powerhouse list is something you might not expect: maintaining a science scrapbook. It sounds so simple, doesn't it? But the study proved that getting students to actively collect, curate, and just physically organize information for themselves is an incredibly effective way to learn.
And finally, the fourth key factor was the simple but oh so powerful act of growing and maintaining a school garden. It's basically a living laboratory. It creates this direct, continuous link between abstract ideas from a textbook and the actual living, breathing world. So, after this whole journey back to 1993, what's the big takeaway? What can all of us, educators, parents, anyone who cares about learning, take from these findings today? Well, the study lays out some really clear recommendations. It says schools should provide expert guidance for these activities, make sure they tie directly back to the curriculum, and really embrace things like scrapbooks and school gardens as honest-to-goodness core teaching tools.
And all that brings us to the real heart of it, the core finding. The best methods aren't the big, flashy, one-time events like a science festival or a museum trip. No, they're the practical, ongoing projects: a garden, a club, a scrapbook. The kinds of things that put students right in the driver's seat of their own discovery. And so, this 30-year-old research leaves us with one last, kind of provocative thought. It's been over 3 decades since this blueprint was spelled out so clearly. So the question is, do these simple, powerful, and statistically proven ideas from 1993 still hold the key to inspiring the next generation of scientists today?